The basic form of exponential functions is y equals a times b to the x power, where a and b are both constants. If a and b are both constants, how are you going to be able to tell the difference between a and b? B has the exponent, right? B has a power, something raised to something, okay? So, if we're looking at this number 1, if we're looking at number 1, what is A? 3. Because there's no power. What is B? 2. Because it does have a power, in this case of x, right? So, let's go through some of these problems real quick, okay? 2 to the 0 power. 1 times 3. 1 times 3. Okay, good, sorry. 2 to the first power. 2 times 3. 6. 2 squared. 4 times 3. 12. 2 to the third power. 8. 8 times 3. 24. 2 to the fourth power. 2 times 2 times 2 times 2. 16. 2 times 3. 48. Okay? Oh, I forgot to tell you. We've got to do these 6 tables, and then we have to answer questions about them. So as we're going through, let me show you what we're going to do. Let's find the ratio real quick. To find a ratio in a table, you take a term and divide by the previous term. 2. Take a term, divide by the previous term. 2. Take a term, divide by the previous term. 2. Take a term and divide by the previous term. 2. So as we finish each problem, we're not conversing. We're not going to answer questions. We're going to go, Number 2. What's A? 2. Because? No power. What about B? 3 because it has a power. Right? So, wait, can we do any of these in the calculator? All of them, right? But we're just kind of using our brain for a little while. So I'm sorry for those of you who forgot yours today. You'll be fine. Okay? 3 to the 0 power. 1 times 2. 2. 3 to the first power. 3 times 2. 6. 3 squared. 9 times 2. 18. 3 to the third power. 27 times 2. 54. 3 to the fourth power. 81. 81 times 2. 162. How do we find the ratio? Take a term, divide it by the term before it. What's 18 divided by 6? What's 54 divided by 18? Wait, do you know that, or you already see a pattern?
I know that.
So those of you who know it, good. Those of you who are seeing a pattern, be careful. Cuidado. That's Spanish for be careful or caution. Cuidado. What's 162 divided by 54? 3. Okay? So we finished that problem, so Number 3. What's A? Okay, so half of you are right and half of you are not, because I heard about half of you say 1 and half of you say 0. What do you got? What do you think?
0.
What happens when you multiply something by 1?
Same.
What happens when you multiply something by 0?
0.
So what is A in this case? It has to be 1. Okay? If I multiply it by 0, the whole equation is just y equals 0. That's not what I need, is it? It's not what I want, and that's not what's there. Okay? So what's B? 6. Okay, so 6 to the 0 power. 1. 6 to the first power. 6. 6 to the second power. 36. 6 to the third power. I know that one. 6 to the fourth power. 1296. Anybody got it?
1296.
1296. Yes. Common ratio. 6 divided by 1. 36 divided by 6. 216 divided by 36. 1296 divided by 216. It's 6. That's okay too. You can go. Huh. That's okay. Now what about this one? What about 4? What's A? 8. What's B? 0.5. Okay? Alright, here we go. 0.5 to the 0 power. 1 times 8? 8. 0.5 to the first power. 0.5 times 8? Half of 8? 4. Okay? 0.5 to the second power is 0.25. 0.25 times 8? A fourth of 8? 2. 0.5 to the third power is 0.125 times 8 is 1. 0.5 to the fourth power is 0.625 times 8, 0.5. Common ratio. Wait, what? Huh. You think it's 0.5? This kid last period was like, it's 2. Because 4 times 2 is 8. 2 times 4 is 4. Oh, we're dividing, not multiplying. That kid was going backwards, right? Okay. So 4 divided by 8 is not 2. I almost wrote 2. 0.5. 2 divided by 4, 0.5. 1 divided by 2, 0.5. Half divided by 1, 0.5. Number 5. A, 100. B, 0.5. Okay. 0.5 to the 0 power. 1 times 100. 100. 0.5 to the first power. 0.5 times 100. 50. 0.5 squared is 0.25. You know that too, don't you? Because what's 5 times 5? But we got decimal points to mess with. It's already 1 decimal point for each, so you're going to end up with 2 places after the decimal point, so 0.25. So a fourth of 100? 25. 0.5 to the third power. 0.125 times 100? 12.5. 0.5 to the fourth power is 0.625 times 100. So it's 0.25. 50 divided by 100. 0.5. 25 divided by 50. 0.5. 12.5 divided by 25. 0.5. 6.25 divided by 12.5. 0.5. Number 6. A, 200. B, 0.8. Okay, I'm going to need some help on this one. I can get a certain ways down the table, but then I mess up after that. 0.8 to the 0 power. 1 times 200. 200. 0.8 squared is 0.64 times 200. I think it's 160. Is that right? Okay. 0.8 to the... Oh, what did I do? I wrote it right. I said it wrong. Can I say it right? 0.8 to the first power is 0.8 times 200 is 160. 0.8 squared is 0.64. Times 200, 128. 0.8 to the third power, I don't know that one. So times 200 is 102.4. Is that right? Okay, so 0.8 to the fourth power, and then times 200. 81.92. Thank you. So 160 divided by 200. 0.8. 128 divided by 160. 0.8. 102.4 divided by 128. 0.8. 81.92 divided by 102.4. Now, someone please make an observation about these tables. The ratio is what? The same as B? Are you sure? Every time? Knowing how I feel about saying every time or always or never?
Yes.
Point B is, or sorry, the ratio is always B? Yes. What effect does B have on the table? It's the common ratio. It's the common ratio, okay? The other word I want you to keep in the back of your head when we're talking about this is it's the pattern. Okay? Some of you tell me how horrible you are at math, but you can see it patterns amazingly easy, which means you're not bad at math. Okay? Any other observations? Maybe about A? Does A show up in the table? Ever? Oh, it always shows up in the table? Where? Always. A always shows up when x equals 0? Yeah. A always shows up in the table where x equals 0. Okay, can I have a qualifier real quick? Can I say something to make sure that we understand when we're talking about always? We are talking about exponential functions, right? Okay, I don't want you to think we're talking about just some random function and a is going to be where x equals 0. We're talking about exponential functions here. Okay? What would this look like if I wrote it as a point? 0, A. That's going to be important for the next page. You ready?
Yes.
Okay. Let's make sure we have defined A and B and know some other stuff about B. That's important. So for the functions in the form y equals A times B to the x, for exponential functions, what is A? We're going to call it the initial amount. What do you think I mean by that? Yeah, what you start with, right? Now, the definition that would make more sense compared to the tables that we just looked at would be where x equals 0, right? And we could write that by saying 0a. Wait, what's that called? 0a. That is the y-intercept. Okay. So what's b? Common ratio. Very good. We may have to look back at the previous page, look back at the other side, but I need you to tell me when y values are increasing. When do the y values increase? Some people said it's a whole number, and that's close. Okay, it's close. But we want to be more specific. Okay, we want to say when y values are increasing when b is greater than 1. Y values increase when b is greater than 1. When do y values decrease? That's super close. When b is less than 1 and greater than 0. Okay? Now, notice I don't have any equal signs in there, right? Like if b equals 1, and we'll talk about that in just a minute. Okay? So, can we go backwards? Over here on this side, I said, here's the equation. Tell me a and b, and give me the table and common ratio. What if this time I say, here's the table, give me the common ratio a and b? Can we do that? Okay, so what do you want to do first? What do you want to tell me first? That a is 5. How do you know that a is 5? It's where x equals 0 in the table, right? That's where a is. We could find the ratio to find b. So what's 20 divided by 5? 4. What's 80 divided by 20? 4. Wait, why can't I just do the first two terms and know that's the common ratio? Because it might not always be the same. And what happens if it's not the same? Something's wrong, right? We're probably not dealing with an exponential function. All right? If it's an exponential function, our ratio should be the same. But we don't ever assume it's the same. We find it because it's really not that difficult, is it? 320 divided by 80? 4. 1280 divided by 320? 4. So what's b? 4. Do I have enough information to write the equation? Okay, so the equation is y equals 5 times, how do we say that? 5 times 4 to the x. Yeah, 5 times 4 to the x. We could say 5 times 4 raised to the x power. We could say 5 times 4 raised to the x. We'd say 5 times 4 to the x. As long as you don't say 5 times 4x, because that's linear, isn't it? That's not exponential, which is what we need. We good? 8. What do you know? A is 2. 18 divided by 2, 9. 162 divided by 18, 9. 1,458 divided by 162, 9. Good. 13,122 divided by 1,458, 9. So we know that b is 9, and we know the equation is y equals 2, yes, times 9 to the x. Yeah. Okay so far? I'm going to try to trick you now. What do you know? A equals 16. B? 24 divided by 16. 1.5. 36 divided by 24. 1.5. 54 divided by 36. 1.5. 81 divided by 54. 1.5. So b is 1.5. So what's the equation? Y equals 16, times 1.5 to the x. Very good. So where was the trick? What do you think people do to get this one wrong? Well, a lot of times they put 8. 8. Something like that. Where did they get 8? they subtracted. Okay? Yeah, don't do that. No, not at all. Okay? We are dividing, right? All right, what about number 10, the last one?
500. A is 500.
A is 500.
B is 0.4.
How do you know B is 0.4?
200
200
by 200.
by 500,
And 80 by 200.
80 by 200, 32 by 80, and 12.8 by 32. So we do know for sure that B is 4, which gives us an equation of,
Y equals 500 times 0.4.
perfect. Confident? Okay. Then look at these two on the side. It says complete these two tables, and then why do you think we don't usually use these? Well, let's figure out what the tables look like first, okay? 1 to the 0 power. 1 times 4? 4. 1 to the first power. 1 times 4? 4. 1 squared times 4. Okay. 1 to the third power. 1 times 4? Did I break it? No. X is 0, y is 4. X is 1, y is 4. X is 2, y is 4. X is 3, y is 4. Is that exponential?
No.
That's just a horizontal line, isn't it? Yeah, I know there's an exponent in the problem, but it's a base of 1. It just doesn't give me any other value than 1. Okay? So can you see why we wouldn't use that? Can you see why we didn't use any, like, less than or equal, greater than or equal signs up here? Okay? What about this last one right here? What if B was a negative number? Negative 2 to the 0 power. 1 times 4? 4. Negative 2 to the first power. Negative 2 times 4? Negative 8. Negative 2 to the second power. 4. 4 times 4. 16. Negative 2 to the third power. Negative 8 times 4. Negative 32.
Does it go like this?
Do you have it?
No, I'm just saying.
I'm going to put it in the calculator real quick so you can see it. Control T, go away. Tab. So it's 4 times negative 2 raised to the x power. I have to change my window back. Keep watching. Keep watching. Maybe mine won't do it. Oh, yep, it did.
That was like scary movies.
Scary face will pop up on screen. That's kind of like a scary face though, isn't it? You want to try to graph that your own self?
Nope.
The calculator is panicking a little bit. Okay? The calculator wants to connect the pixels that it's supposed to connect, but sometimes it connects pixels even when it's not supposed to, when there's not enough pixels to do what it wants to do. And that's what's happening right here. Okay? So do you see why we don't usually use this one? A negative number as our base. Okay? All right, so the other worksheet that we have to do today is called Money, Money, Money. A lot of times when we do word problems, and we've talked about this in the past, a lot of times when we do word problems, we really have to suspend reality because the word problems that they give us are just kind of ridiculous. They're just trying to get us to the math. This one is not. This one is very real. Okay? To help with the cost of tuition, room, and board, you take out a loan of $20,000 for college. You do not have to make any payments on the loan until you leave school. That is true. That's not just something made up for a worksheet, okay? It's really funny because when you finish college, that's when you have to start paying on your loans. But teachers get an extra couple years to start paying on their loans because they know how bad teachers' salaries are. Isn't that sad? Yeah, it's really sad. Okay. However, the loan amount accumulates interest at a rate of 12% annually. If at all possible, please don't get 12% interest. Please look for like 2 or 3 or 4 or something like that. The lower interest rate, the better, the less money you're going to have to pay back. Okay? So if 12 is all you can find, look harder. All right? To determine how much you owe after X years of school, complete the table and the graph. Now, here's the only part of this that's not real. Okay? A bank is not, or a lending company is not going to round it to the whole dollar. It's going to round it like money, so it'll round to the 100th, you know, the second decimal place. We're just trying to make this a little bit easier on ourselves. Okay? All right, so if I start at 20,000, how much am I going to owe after the first year? How would I figure that out? I'm going to multiply 20,000 by 0.12. Okay, I'm going to write my work on the back for just a second. 20,000 times 0.12. What does that give me? What is it? 2,400? What do I have to do with that 2,400? Add it to the original amount that I borrowed, right? What I borrowed. So I have 22,400. Is there an easier way? Yes. Okay, I'm going to show you this example because I know how much you loved factoring. Okay, so let's just call it X for now because that's easier to deal with than the 20,000. Okay, we know that's what it's going to represent, but let's just call it X for now. Okay, this is how much I borrowed. And if I multiply that by 0.12, then I have to add it back to the original amount I borrowed, right? Well, what if I took this and factored out an X? If I factor out an X, what's left in this term if I factor out an X? 0.12. What's left in this term if I factor out an X? A 1, right? A 1. Wait, can I do that math? Do I know what 0.12 plus 1 is? 1.12. Now if we put that 20,000 back into this problem, what is 20,000 times 1.12? 22,400. Okay? That's going to be real helpful. First of all, it's really helpful if you're at the store. Right? I don't want to have to sit and take what I'm going to owe, or if I know I have so much money and I want to be able to buy stuff, you know, with that money, but I can't spend more than that because I don't have any more than that. Take what you know you owe, multiply it by the tax, and then add the original amount. I don't want to do that. I want to be able to multiply it by if we're talking about sales tax, 1.0825, right? Okay? So this will help on more than just this problem. Okay? So go back to the front. So we know that this is 22,400. I need to know what you know about this. How do I get 2 years? Do I add another 2,400? Is that how interest works? Do I just add the same amount from the very beginning? Or is the interest calculated on what I owe now? It's what I owe now, right? So I have to take 22,400 and multiply that by 1.12. What is 22,400 times 1.12? Louder, please. I'm sorry. 25,088. So how do we get the rest? Multiply that by 1.12, right? What do we get here? I am correct. I'm rounding it to the nearest whole dollar.
So would it be 28,099?
Perfect. 28,099. Because it's 98.9 or something like that, isn't it? 6. Okay. So then I have to take 28,099 and multiply that by 1.12. So 31,470. Wait, is that right? So 71. Okay, so look, what we need to do is we need to make sure that we're multiplying what we wrote, the number that we rounded, by 1.12. Don't just keep on going off of that number. Type in the new number again, otherwise our rounding will probably be off. Okay, so what is 31,471 times 1.12?
35,247.
I didn't hear the last three, I'm sorry.
247.
247. And now multiply that by 1.12.
Well, shouldn't it be 248?
I don't know, let me look. 31,471 times 1.12 would be, oh, it should be 48, shouldn't it? 248? Because what I got was 35,247.5. Yes? And so 35,248 times 1.12, 39,478. Right? Gosh, that was annoying. Does that seem annoying to you guys? And I wish we had a way to write an equation for it instead. Like an exponential equation?
We do.
Oh, we do. How do we know how to write exponential equations?
Because you find the ratio, and then the first one's...
Do we know the ratio?
It's 1.12.
Okay. Do we know the initial amount?
20,000.
So what is our equation then?
20,000. 1.12 to the x.
20,000 times 1.12 to the x power. Nice job, Brett.
Give me a shout out.
Except you decide after you graduate you're going to go to law school. So you're still going to be in college. So you're still not having to pay off your loans, right? You're going to law school. Except when we go to law school, it takes us 8 years. So am I going to multiply this by 1.12 and then multiply the next one by 1.12, or is there an easier way?
Raise it to 8.
Can't I say 20,000 times 1.12 raised to the 8th? Did you guys get the same thing I did? $49,519. Except then you decide you're too smart for law school and you're going to go to medical school instead. And you're going to be in school for 12 years. Just raise it to the 12th power, right? 1.12 raised to the 12th power. $77,920. So your other favorite thing to talk about, domain and range. In this particular problem, domain is what? The years in school. Okay? So our domain in this particular problem is years. What kind of numbers can we talk about if we're talking about years? Can we have 1.5 years? So we can have -3 years? No. What kind of numbers are we talking about? Positive numbers, right? Okay? So x has to be greater than or equal to 0. What about range? Y is going to have to be greater than or equal to what? 20,000? But I thought it was dollars. Isn't it dollars? Can't I have like $25? Can I talk about that?
You can't have negative dollars.
But it asked for problem situation, didn't it? For this thing. And we started out by owing $20,000. Not less than that, but starting at $20,000. Okay? Any questions? All right, so you do have this other problem to do. Okay, for homework, get this the other half of that page finished, and I will check that next time I see you. Have a great day.